Hi students, welcome to Methodology classes. Today in this class we are going to discuss some important questions from NCERT Exemplar 1.3 and 1.4 and some questions from the R.D. Sharma and from RMO books. I hope you would be enjoying the sessions. So this will be the final lecture for the chapter 1 of class 10th NCERT and higher level questions. So let's start. So the question number 1. If the LCM of A and 18 is 36 and the HCF of A and 18 is 2, then A is equal to. So here there is a number 18 and a variable A and their LCM and HCF is given, and we have to find out the possible values of A. And one of the options will be true. So let us see here. Now LCM of A and 18 is 36. So this is question number 1. LCM of A and 18 is 36. So we have to just focus on the basics. Now what is LCM? How we find out the LCM? We find out the LCM by taking the highest power of the prime numbers present in A and 18 both. So A is unknown, so 18 here we can see its prime factorization is 3 square times 2. So 18's prime factorization is 3 square and 2, and the LCM prime factorization of 36 is 3 square and 2 square, 3 square times 2 square. So LCM of A and 18 is 36, means highest power of the prime factors present in 18 and A is 3 to the power 2 and 2 to the power 2. So 18 already contains 2 to the power 2, but it has 2 to the power 1 only. So 80A must have at least 2 square. Then only its LCM will be possible to be 3 square times 2 square. And again it is given that HCF of A and 18 is 2. So if A is equal to 2 square also, then also if I want to find out HCF of A and 18, HCF of A and 18. So here in HCF what we do? We take the least power of the common factor. So in A and 18 only 2 is common and its least power is 2. So its HCF will be 2. So in this way we can say if LCM of A and 18 is 36 and HCF of A and 18 is 2, then if it is 2 then it's not possible, because in that case LCM will not be 36. So this is not possible. 3, then HCF will not be possible to be 2. And then 4, we got the answer, and 1, then HCF will become 1 only. So the answer will be 4. Now moving to the question number 2. If n is a natural number, then 9 raised to power 2n minus 4 raised to power 2n is always divisible by. So this question is based on factorization. In class 9th we have studied polynomials, factor theorem. So 9 raised to power 2n minus 4 raised to power 2n is always divisible by. So to understand this, if we take a function a to the power n, and let us assume it to be a function of a, and b is constant here. So the factor theorem says that if f of x is any polynomial and f of a is equal to 0, then x minus a is a factor of that. It's a function of a, so a is the variable here. So if a is equal to b, then f of b will become b to the power n minus b to the power n is equal to 0. So by factor theorem, we can say that a minus b is a factor of a to the power n minus b to the power n, and here we have assumed that n is even. Now similarly, if we take a is equal to minus b, then also f of minus b will become minus b to the power n minus b to the power n. Now n is even here, so we can write b to the power n minus b to the power n is equal to 0. So again, f of minus b is also 0. So we can say a plus b is a factor of a to the power n minus b to the power n if n is even. So we saw that if the powers of a to the power n minus b to the power n means n is even, then a minus b and a plus b is always a factor of a to the power n minus b to the power n. So in this way, from that example, we can see that if n is a natural number, then 9 to the power 2n minus 4 to the power 2n means the power of 9 and 4 both are equal and even. So it will always be divisible by 9 minus 4 and 9 plus 4. So that is 5 and 30. So answer C will be there. Now third is just a simple application of the question number 2 only. If n is a natural number, then 6 to the power n minus 5 to the power n always ends with. So we have to see here question number 3. Now if we just think, then the digits 0, 1, 5 and 6. 0, 1, 5, 6 are the digits whose any power ends with the same number. Like if we take 5 to the power 1, then it will be 5. 5 square will be 25. 5 cube will be 125. Similarly, 6 to the power 1 is 6. 6 square is 36. 6 cube is 216. So 0, 1, 5, 6 are the digits whose any power ends with the same digit. So 6 to the power n units place will be 6 and 5 to the power n units place will be 5. So 6 to the power n minus 5 to the power n will always end with 1. So we can say if n is a natural number, then 6 to the power n minus 5 to the power n always ends with 1. We don't need to worry about the remaining numbers. We have to just think about the units digit only. Now question number 4. The LCM and HCF of two rational numbers are equal. So LCM and HCF are equal. Then the numbers must be. So LCM is the number which is either greater or equal to the greatest of the two numbers. And HCF of two numbers is always less than or equal to the smaller of the two numbers. So if both the numbers, so HCF can be only smaller than, can be equal or smaller to the smallest number, and LCM will be greater or equal to the greatest of the number. So if both HCF and LCM are equal, so this will be possible only if the two numbers are equal. Otherwise, LCM and HCF cannot be equal because LCM is greater than greatest of the two numbers and HCF is smaller than smaller of the two numbers. So if both are equal, then a smaller number and a greater number must be equal. So we can say if the LCM and HCF of two numbers are equal, this will be possible only if both the numbers are equal. Question number 5. The remainder when the square of any prime number greater than 3 is divided by 6. The remainder when the square of any prime number greater than 3 is divided by 6. So let us try to understand this problem. So for this, let us try to note down some prime numbers which are greater than 3. So greater than 3 prime numbers are 5, 7, 11, 13, 17, 23, 29 and so on. So if we examine it, so I can write 5 as 6 minus 1, 7 as 6 plus 1, 11 is 6 into 2 minus 1, 13 is 6 into 2 plus 1, and 17 is 6 into 3 minus 1, and 23 is 6 into 4 minus 1, and 29 is 6 into 5 minus 1. So in this way, we can see that all the prime numbers which are greater than 3 can be written in the form of 6k plus minus 1. All the prime numbers which are greater than 3 can be written as 6k plus minus 1. but its reverse is not true. What I mean by that is, if any number can be written in the form of 6k plus minus 1, it's not necessary that it is a prime number. So prime number can be written in the form of 6k plus minus 1, always written in the form of 6k plus minus 1, but any number which can be written in the form of 6k plus minus 1 is not necessarily a prime number. So we got this idea. Now let us see the question. The remainder when the square of any prime number greater than 3 is divided by 6. So any prime number greater than 3 can be written in this form, and if I square it, so we can apply the formula 6k plus minus a plus minus b whole square. So we can write a square, that is 36k square, plus b square, that is 1, and plus minus 2ab is 1. So 36k square and plus minus, I can write it as 12k plus 1. So these two numbers are multiples of 6. So whenever we will divide this number 6k plus minus 1 whole square by 6, we will get the remainder as 1, because these two will be divisible by 6 and only remaining will be 1. So we can say that the remainder when the square of any prime number greater than 3 is divided by 6 is 1. Now question number 6, given any positive integer k, find k consecutive composite numbers. So if there is any positive integer k, we have to find out k consecutive composite numbers. So question number 6. Now it will be very hard to think like this to find out k composite numbers. Now k can be 100 or k can be 1000. So we can just make a number k plus 1 factorial. And to find out composite numbers, we can write as plus 2. So 2 will be common in k plus 1 factorial and this 2. So we will have a divisor of this number which is other than 1 and the number itself. Similarly, we can write k plus 1 factorial plus 3. Again 3 will be common in this, and similarly we can go for k plus 1 factorial plus k plus 1. So starting with 2 and ending with k plus 1, we will be having k composite numbers because each number will have a divisor other than 1 and itself. So 6 is done. Question number 7. So that the square of any positive integer is either of the form 4q or 4q plus 1 for some integer q. So let us think. Let n be any integer and if we divide it by 2, then it will be of the form n is equal to 2r or 2r plus 1. These are the only two possibilities where r is any integer. So now if I square it, n square, so 2r whole square will be 4r square. So we can write this as what we want to show, 4q or 4q plus 1. So this is of the form 4q where q is equal to r square. Now if n is of the form 2r plus 1, then n square will be 2r plus 1 whole square. So we can write it by using the formula a plus b whole square. It will be 4r square plus 4r plus 1. We can take 4 common, so r square plus r plus 1. Now r square plus r will be some integer, so we can write it as q plus 1, where q is equal to r square plus r. So we saw that if n is any positive integer, then its square will always be of the form 4q or 4q plus 1. So we solved question number 7. Now moving to the question number 8. if n is an odd integer, then show that n square minus 1 is divisible by 8. So if n is an odd integer, then show that n square minus 1 is divisible by 8. So this question is just based on the properties of the integers. Let n is equal to 2r plus 1 be an odd integer. Then we have to show that n square minus 1 is divisible by 8. So if n is equal to 2r plus 1, then n square minus 1 will be 2r plus 1 whole square minus 1. So if I open it using a plus b whole square, so it will be 4r square plus 2ab means 4r plus 1 minus 1. So plus 1 minus 1 will cancel out. We can take 4r common, so remaining will be r plus 1. Now 4 and r times r plus 1 is a product of two consecutive integers, and we know that product of two consecutive integers is always a multiple of 2. So we can write it as 2q, where 2q is equal to r times r plus 1. So it will be 8 times q. So from here we can say that n square minus 1 will always be a multiple of 8. It means it will always be divisible by 8. Question number 9. So that 12 to the power n cannot end with the digit 0 or 5 for any natural number n. Cannot end with the digit 0 or 5 for any natural number n. So let's question number 9. 12 to the power n cannot end with 0 or 5. So if any number ends with 0 or 5, so that number must be divisible by 5. And if any number is divisible by 5, then its prime factorization will contain at least 1 5. So let us see the prime factorization of 12 to the power n. So 12 can be factorized as 2 square times 3 to the power n. So if I open it, so it will be 2 to the power n times 3 to the power n. Now we can see that 12 to the power n, its prime factorization does not contain any 5, and if its prime factorization does not contain any 5, then it cannot end with 0 or 5. So in this way we can say that 12 to the power n cannot end with the digit 0 or 5 for any natural number n. Now coming to the question number 10, prove that 1 and only 1 out of n, n plus 2, n plus 4 is divisible by 3, where n is any positive integer. So let us see this question number 10. So there are three numbers given, n, n plus 2 and n plus 4, where n is any positive integer. So we have to show that 1 and only 1 out of this will be divisible by 3. Now if we divide n by 3, so it will be of the form 3r or 3r plus 1 or 3r plus 2. So these are the three possibilities for n. Now if n is equal to 3r, then n will be divisible by 3. If n is equal to 3r plus 1, then n plus 2 will become 3r plus 1 plus 2, that is 3r plus 3. So if n is equal to 3r plus 1, means when n is divided by 3 it leaves remainder 1, then n plus 2 will become divisible by 3, and only this will be divisible by 3. N will obviously not be divisible by 3 because it is leaving remainder 1, and if we see n plus 4, then it will become 3r plus 1 plus 4, so that will be 3r plus 3 plus 2. So these two are multiples of 3, so on dividing n plus 4 by 3, we will be getting a remainder 2. Now if n is equal to 3r plus 2, then obviously n is not divisible by 3. If we check n plus 2, then it will become 3r plus 2 plus 2, so that will be 3r, and 2 plus 2 is 4, so we can write it as 3 plus 1. So these two numbers are multiples of 3, so on dividing n plus 2 by 3, we will be getting remainder 1. Now if we see n plus 4, so that will become 3r plus 2 plus 4, so that will become 3r plus 6. Now 3r and 6 both are multiples of 3. So n plus 4 will be divisible by 3. So we saw that if n is any positive integer, then n out of n, n plus 2, n plus 4, only one of them will be divisible by 3. So in this way, we studied some important questions and conceptual questions from the chapter number 1. I hope you would have enjoyed the session. Now, if you liked the video, please like and subscribe my channel.